Okay, we're back for the second part of this video. We're going to continue on and we'll start with percentages. So let's talk about percent. So a percent is a ratio. As a percent, a ratio is a comparison of two numbers by division. If we have a part that is some percent of the whole, then the percent equals a part over the whole, or the part divided by the whole. Or you could say the percent times the whole equals the part. So a rate is a ratio of two quantities. So when you think about speed, 500 miles per hour, that is a rate. It is 500 miles over 1 hour. A unit rate is a rate with a denominator of 1. In this case, this would be a unit rate. Let's talk about change a little bit. So absolute change equals the ending quantity minus the starting quantity, and you take the absolute value. So remember, these bars, these are the absolute values. So the absolute change is always positive. Relative change is the absolute change divided by the starting quantity. So let's try a couple of examples. A product's price increased from $40 to $50. Find both the relative and absolute change in percentages. So let's start off with the absolute change, which is AC. That is your ending value, which is 50, minus your starting value, which is 40. So the absolute change would be 10, or 10%. The relative change is the absolute change divided by the starting quantity. So 10 divided by 440 is 0.25. So the absolute change, the relative change is 25%. Let's talk a little bit about exponents. There's a bunch of exponent rules we need to go through. So when you talk about exponents, exponents are made up of a base and an exponent. The exponent tells the base how many times to multiply itself together. So if I have 2 to the third, the 3 tells the 2, which is the base, to multiply itself 3 times, and that equals 8. In this situation here, you need to make sure you understand what the parenthesis does and what this negative 3 squared means and what's actually being squared. In this first case, you need to understand that this needs to be rewritten as negative 1 times 3 squared. So negative 1 times 9 equals negative 9. Whereas this time the whole quantity is being squared. So it's negative 3 times negative 3 equals 9. So that's the whole quantity. The product rule, when the bases are the same, you add the exponents. So here's an example. 2 to the third times 2 to the fourth. Remember, 2 to the third is the same as 2 times 2 times 2. And 2 to the fourth is the same as 2 times 2 times 2 times 2. So that would be 7 2's multiplied together. So it's 2 to the 7th. The quotient rule says if the bases are the same, you subtract the exponents. So here's an example. X to the fifth divided by x squared. So remember, x to the fifth is the same as x times x times x times x. And x squared is the same as x times x. And if you remember back from dividing fractions, you can actually cancel out like products. So notice how I cancel out these x's, which leaves x to the third on top, which is same as 5 minus 2 is 3. So x to the 5 minus 2 equals x to the third. Here's a few examples. Notice this first one, the base is the same, so you add the exponents. So 4 plus 5 is 9. Number 2, notice the bases are the same, so you subtract the exponents. 7 minus 2 is 5. Now if I take a power to a power, then you multiply the exponents. Here's an example. So if I have x squared, that's the same. Remember, this exponent here tells the base, which is x squared, to multiply by itself twice. So x squared times x squared is x to the fourth. If I have x to the fourth squared, that's going to be the same as x to the fourth times x to the fourth. The base is the same, so I add the exponents. Notice it's the same as 4 times 2 is 8. So a product raised to the power is the same as the powers times each other. couple of things you need to understand. Any number to the first power, any base to the first power is just the base, and any base to the 0 power is 1. So like 3 to the 0 is 1, 8 to the 0 is 1. If I have a complex fraction like x to the 10th over y to the 0 power, that's still 1. Negative exponents, that's something you need to understand too. You should not have negative exponents. You need to make sure you remove them. It's kind of like having a non-reduced fraction. Negative exponents need to be moved. So if I have a number like a to the negative 2, remember that's a to the negative 2 over 1, that's the same as 1 over a squared. If I have 1 over x to the negative 3, that's the same as x over 3. Here's a couple examples. Scientific notation. A couple things about scientific notation. It looks like 2 times 10 to the second power, or 3.2 times 10 to the negative 3. And in either case, the exponents on the power of 10 will either be positive or negative. If the exponent is positive, this number in front gets bigger. If the exponent is negative, the number in front gets smaller, because essentially you're moving the decimal point left or right. If the exponent is a positive, you're going to move the decimal to the right. So this is going to be right. This way. If it's negative, you're moving it to the left. So when you multiply exponents, you treat them when you multiply scientific notation, you treat them just like you just learned with the scientific notation, with the exponent rules. You multiply the numbers. 3 times 2 is 6, and you add the bases, because in both cases the bases are 10. So 10 to the 4th times 10 to the 5th is 10 to the 4 plus 5, or 10 to the 9th. So 6 times 10 to the 9th. If you have a fraction, you do the same thing. You divide the numbers. 5 divided by 1 is 5. 7 minus 3 is 4. So when we solve equations, there's some things we need to understand. A constant is a fixed value or a number that does not change. So a constant would be like 2. A variable is a symbol that represents a value or a quantity that can change or vary based on the situation. So that could be like x. X could be anything. An algebraic expression is a mathematical phrase or combination of numbers, variables, and arithmetic operations such as addition, subtraction, multiplication, division. So that would be like 2x squared plus y. Now in this case, remember, this is a constant, x is a variable, y is a variable, and the constant on the y is a 1. If you want to evaluate an algebraic expression, what you're going to do is, if you have an algebraic expression like x plus 2, you're going to take the 2 and you're going to put it in wherever you see an x. So that's where 2 plus 2 plus 2 equals 4. So if I have x squared when x is 4, that's the same as 4 squared, or 16. Now, an equation is a mathematical statement that shows that the quantity of two expressions, typically separated by an equal sign, it states that the two expressions have the same value. So if I have an expression like 2x, and I say that's equal to y, this is an equation. This is saying that these are equal. If I have 2x plus 1 equals 3, I could ask you to find out what x is. You'd have to solve for x. So here are your steps to solve for x. So you multiply declarative fractions, or decimals. Simplify each side by clearing parentheses and combining like terms. Add or subtract to isolate the variable. Multiply or divide to isolate the variable. Check your solution. So there are 3 different ways you can have a solution. You can have one solution where your variable equals a number, like x equals 2. You can have no solution when you work the problem down and you get a equation like 2 equals 3. That would be false, because this is a false statement. Since it's a false statement, that means there's no solution. And many solutions would be if you get a equation where it's true, like 4 is equal to 4. That's always true. It's always a true statement. That would be many solutions. So the three ways this equation can be answered is: one solution, that's probably the most of the time; No solution, that's when your statement is false. And many solution, that's when your statement is true. So let's try it. Let me clean this up a little bit. And then we will see what we can get. We'll try some of these. Clean this up. So let's take a look at the first one. So remember, our first one is 2x over 3 plus 5 equals 3x minus 4. If you read back to your suggestions, it says multiply to clear the fractions. So if we want to multiply to clear the fractions, what that means is we're going to multiply every single term by 3. So this one cancels. So I got 2x plus 15 equals 9x minus 20. Then the next step would be to simplify each side by clearing parentheses. We don't have any parentheses. Add or subtract to isolate the variable. So let's add or subtract. What I'm going to do is I'm going to subtract 2x. Subtract 2x. I'm going to add 20 and add 20. So now I get 35 equals 7x. Then the next step would be to divide to isolate the variable. So I'm going to divide by 7. So x equals 5. So that's how you solve an equation. This next one, if we look at our steps, it says multiply, divide, to clear fractions. We don't have any fractions. Simplify each side by clearing parentheses. Let's clear parentheses. So we're going to use the distributive property. So that'd be 4y minus 12 equals 4y plus 5. Now in this situation, you notice that if I subtract off the 4y, this goes away. So I'm down to negative 12 equals 5. Negative 12 can never equal 5, so this is a false statement. So the answer here would be no solution. And the last one, let's take a look at it. The first step would be to multiply to clear fractions. Let's multiply to clear fractions. So the way we're going to do that is we're going to multiply every single term by 2. So I'm going to get 4z plus 4 equals 4z plus 4. And if you notice, whoops, I put an x. This should be a z. It should be a 4z plus 4. Now if you notice, this side is equal to this side. That is always going to be a true statement. So this is a true statement. So the answer would be many solutions. Okay. So that pretty much takes care of this section. Hope you enjoy. If you have questions, please let me know.